Hi, my name is Brooke Wagoner, and I'm in Distinguished Scholar Science. And the title of my project is The Effects of Partially Hydrogenated Vegetable Oil on the Formation of Chocolate Bloom. So first, here's the poster that I submitted to the Greater Kansas City Science and Engineering Fair. And this presentation is kind of an overview of this poster, but this is what I've been working on for the past 2 semesters. So the first question is, what is chocolate bloom? So bloom is a substance that forms on the surface of chocolate either during production or after production, and it's basically the pore crystallization of cocoa butter. So this can either happen during production where it's not crystallized properly initially, or after production where it's slightly melted and then recrystallized, either in storage, and this can happen just in hotter environments. So as you can see here in this image, the chocolate on the left has no bloom, and then the chocolate on the right has bloom. So there are no physical negative effects like health-wise on the consumer, but it does have like a bad texture or mouthfeel, and it doesn't look great either. So that's not great for chocolate companies. And it can also indicate poor quality. So that can also be a concern for chocolate companies. So the inspiration for this project came from my sophomore year where we studied food science and distinguished scholars. And I came across this study about chocolate bloom. And remembering it this year, I was very interested in it. So I wanted to see what I could do with it research-wise. So my research question was, how does the addition of partially hydrogenated vegetable oil to melted chocolate affect the percent of bloom covering the surface? And does the amount of partially hydrogenated vegetable oil added to melted chocolate affect the percent of bloom covering the surface? So my hypothesis was that the addition of the oil will reduce the percent of bloom covering the surface, and that the percent of bloom on the surface of chocolate will also decrease as the amount of oil in the chocolate increases. So for my methodology, I started with vacuum sealable bags, and I weighed 40 grams of Hershey's Special Dark Chocolate and added it to each bag. I used Hershey's Special Dark because Hershey's is just kind of like a middle ground quality, so I didn't want something like super good quality, but I also didn't want a super poor quality chocolate, so Hershey's is kind of in the middle. And I chose dark chocolate, so it has like a greater contrast between the color of bloom, which is very light, and then the color of the chocolate, which is obviously very dark. So next I added the oil to each bag of chocolate. So there are 4 treatment groups. Treatment O had 0% oil by mass. A had 1.5% oil, B had 3% oil, and C had 4.5% oil. So each percent was calculated from the grams of chocolate, and then the amount was added to each bag. And then after that, each bag was vacuum sealed and then added to a sous vide water bath. So a sous vide is like a cooking element that keeps water at a constant temperature. So as you can see on the right, it's this big like black and metal thing. And it kept the water at a constant temperature to ensure that the chocolate was all heated at the same temperature. So while I was in the sous vide bath, I also tempered the chocolate, which means like reducing the temperature of the chocolate slowly over time. So after about 10 minutes, I reduced the temperature of the water bath by about 10 degrees, and I did this twice. And this ensures that the initial crystallization of the cocoa butter is good, so that initial bloom doesn't form. So if I had not done this step, bloom would have formed immediately, rather than tempering it, which ensures that the crystallization is proper. So after the chocolate was melted, I piped it into these pink silicone molds down here. So a randomization process was employed. So there were 3 samples per trial, so that makes 12 samples per trial. And so a number was assigned to each square in the mold, so 12 random numbers were assigned to each mold. And so the mold slots with the lowest 3 numbers were assigned to treatment O, the next lowest 3 numbers were assigned to treatment A, and so on. And this was done to ensure that the placement of the chocolate in the mold doesn't affect the amount of bloom that gets formed on it. So the chocolate sat for 10 days, and on the 10th day, pictures of each sample was taken, and then they were analyzed through the image color extract PHP, which is a computer program that selects 10 colors in the photo and then gives the percent of the color in each photo. So I used the lightest three colors as to be determined as bloom. So the sum of the three lightest colors given by this program were determined to be the percent of the surface covered by bloom. So for my results, I had a bit of an issue with the samples containing oil, so treatments A, B, and C. So the oil wasn't properly emulsified into the chocolate mixture, so that created some streaking, as you can see in the top left and right image. So this also had a very light color, but wasn't bloom. So in my final sums, that kind of threw off my numbers. So to work around this, I took a picture from day one and analyzed them in the same way. So I found the sum of the three lightest colors and then subtracted that from the day 10 sum. So, for example, if day 10 had 20% bloom and day 1 had 10%, then I would subtract that and that would end as 10%. So that would mean that 10% of the surface was covered by bloom in the end. Also, sample B 3.1 was found to be an outlier, so it was removed from the data set. So for statistical analysis, 2 sample t intervals for means were conducted to compare each treatment group to the control and to compare each treatment group to each other. So the means of each treatment group, or of each treatment group were found across the 3 trials, and that can be seen in the graph here on the right. So the blue dot is the mean, and then the black bars are the standard deviation. So as you can see, the means did decrease with the increase of oil added to the chocolate, but through the statistical analysis, it was found that as you can see on the top table on the left, comparing each group to the control, since 0 was not found in any of these intervals, it was found that there is a significant difference between the samples containing oil and not containing oil. And then for the second table, comparing each treatment group to each other, it was so the first value does contain 0. The second value of the second comparison is very close to 0, so I determined that it was too close and not statistically significant enough. But comparing treatment groups C and A, I did determine that that was far enough from 0 and statistically significant. So for my conclusion, I did find that there is significant evidence that the addition of partially hydrogenated vegetable oil decreases the percent of bloom covering the surface, and this supports my first hypothesis. And then there's only significant evidence that samples with 4.5% oil had a smaller mean percent of the chocolate surface covered by bloom compared to samples with 1.5% oil. So as I said in the last slide, only that last interval did not contain 0. So that the hypothesis only supports that one comparison. So this can be applied to chocolate companies in search of the optimal percent of oil added, or percent of oil additive that is added to chocolate to prevent the formation of bloom. So this will help them with like quality and preventing bloom in all of their products. In future research, I would definitely ensure that the chocolate and oil are properly emulsified so I don't have the streaking problem again. And also I would extend the sampling period to about 8 weeks to kind of mimic the production and then storage time after production, since 10 days definitely isn't long enough. So yeah, that's it. Thank you very much. You have a good day.